What is the data model in document databases? How is the data represented and stored? And in what ways are document databases better than relational databases? If you want to find out, let's see together in this video. Hello and welcome. My name is Elhelw. In a previous video, I talked about the differences between relational and NoSQL databases and explained the pros and cons of each. In particular, I talked about the 4 types of NoSQL databases, that is, graph databases, document databases, wide column stores, and key value stores, and explained the differences and how the data is represented in each of them and so on. Today, we are going to talk about one specific kind of NoSQL databases, and that is document databases. Some of the popular examples of document databases that you might be familiar with are MongoDB as well as Couchbase. I will talk about the basics of document databases in this video. There might be some overlap between this video and the previous one, which I will also link in the description as well as up here on the screen in case you want to review it. This video is going to be an overview on document databases, on the document data model, how the data is represented and how can we interact with the data. This is going to be a relatively short video just for those who are not familiar with document databases at all. I will use MongoDB as an example, and there will be more videos that go deeper into MongoDB and document databases after that. But as always, it's better to start with an overview so that people who are not familiar will understand what we're talking about. So let me start by talking about the data model in a document database. How is the data represented? In document databases, we represent data or we store data as collections. A collection is a representation of a group of similar objects or similar entities. This is similar to tables in relational databases. In relational databases, we have tables or relations that represent groups of similar objects. Here, we store them in collections. So you might see like a customers collection or a products collection and so on. Each item inside a collection is a document. Again, this is corresponding to a tuple or a row in relational databases. So over there, a tuple or a row represents a single item inside a table. Here, a document represents an item inside a collection. So if we're talking about the customers collection, for example, then we will have one document for each customer inside that collection. What does a document look like? We're not talking about like a text document or like a PDF document or anything like that. When we are talking about document databases, the documents we're talking about are usually JSON documents. JSON is JavaScript object notation. If you are familiar with JavaScript, then you're probably already familiar with this format. A JSON document is represented as a bunch of key value pairs, usually enclosed within these curly braces. The keys are field names. The values could be anything, pretty much could be atomic values like strings or numbers or dates and whatnot, but they could also be nested documents, and they could also be arrays. So we could have an array that has strings in it, or we could have arrays that have other nested documents and so on. So it's very flexible. Let's see an example here. So this is a document. It's talking about the city of New York. So here is one field, which is city, and the value here is a string, which is New York. Here's another field with a numeric value, population, which has a number as the value. This is another field, location, which has a nested document in it. So the nested document has 2 fields, latitude and longitude. Another field, the top attractions, this is an array. So it has multiple items. In this particular case, the multiple items happen to be strings. So this is an array of strings, again, as a field. We have another field here, which is neighborhoods, which is also an array, but the items in the array are not strings. They are actually nested documents as well. So each item is a document. Each one of these documents has, fields and so on. You could have multiple, levels of nesting, if you will. It's not only one level of nesting. So this is a typical document, what it might look like. One thing to note as well is that we have this field in the beginning, the _ID field. This is a MongoDB specific thing. For each top level document, you usually have this. It's a system field that is added with a system generated ID to be able to reference a particular document. This is used a lot in some queries to be able to get a particular document by its ID and so on. Again, this is a typical document the way it looks like. One thing to note is that even though we see the document in a JSON format, this is not actually how it is internally stored. In the storage, it is stored as something that we call BSON. BSON stands for binary JSON. So basically imagine that you have like a binary representation of this data instead of this text representation. Of course, the binary representation will be much more efficient in terms of storage, in terms of network transfer, and so on. So internally, we store the data as this BSON format, and all the operations and all the queries are applied on this BSON format, and then it is translated to JSON when it is being produced or output to the user or to the application. So this is an important thing to keep in mind as well. When we talked about fields, so you've seen all these different fields in the document, right? So again, to continue the analogy that we're making, the fields are corresponding to the columns or the attributes that we have in the relational database. So basically, again, so to summarize, in relational databases, you have tables. In document database, you have collection. Over there, you have rows. Here you have documents. Over there, you have columns. Here you have fields. In relational databases, within a given table, all the rows must have the same set of columns, right? This is what we refer to as a schema, and we said before that the schema is usually fixed in a table. We don't have this requirement in document databases. The documents in a collection don't always need to have the same set of fields. You could have multiple documents that belong in the same collection, but each of them has different fields. As an example, here let's say we have these two documents in the same collection. Let's call it like a customer or a user collection or something. So each document is describing information about one person. So we have the name, we have the age, those are common fields, but then the first document has a city field, which the second document does not have, and the second document has an email field, which the first document does not have. So it's very common to see things like this, where different documents have different fields while still being part of the same collection. Okay, so what are the advantages of document databases compared to relational databases? Again, if you want to see like the full pros and cons between relational and NoSQL databases, please take a look at the previous video. Here, I'm going to focus only on one aspect of how the data is represented and how does it make it easy or better to be able to access and use this data. So let's look at an example. Suppose we have a users table in relational databases. This table will look something like this. Would have the name, the phone, the birth date, for example, in addition to like some ID. Now, suppose that for these users, I wanted to add an additional phone number for the second user, Bob, for example. The current structure of the table does not allow me to do that. So I need to modify the structure of the table. If I want to add a second phone number, let's say I will add a second column, call it phone number 2, and rename the one that we have to phone number 1. And the table is going to look like this. So I added the second column, I added the new phone number for Bob, but because the schema has to apply to all the rows in the table, so the first row, Alice, has to have that column as well. But because we don't have a value there, then this is added as a null. So again, this is what the table will look like after that modification. So I had to actually update the table structure for this. Now, let's say after some time, I want to add another user, but this user does not have any phone numbers. Instead, they have an email address. Now, the table does not have an email column, so I need to update the structure yet again, add an email column, and then add this new user. And again, because of the fact that the previous users maybe did not have emails, or I wasn't even thinking about it at that point, and this new user doesn't have phone numbers, then we will have nulls as we can see here. So this third user, Tom, doesn't have phone numbers, has an email, and the previous two users do not have email addresses. So again, more nulls in the table. Every time we update the table structure to accommodate new kinds of information, then the amount of nulls increases. If we want to add more phone numbers, for example, or more emails, or let's say you want to add a website for each user, or you want to add their physical address or whatever it is, then you will start modifying the structure over and over, and again, the amount of nulls will increase. Of course, a lot of this can be avoided if you have a good design from the start. You will not completely avoid it, like you will reduce it significantly, but these things will still happen, that you want to update the structure and so on. Of course, there is another thing, which is like data normalization, which we have also talked about in the past, where because of the nature of the data, you might actually want to split it into multiple tables. So this is one thing that we can do here. We can split it, and we say the phone numbers are going to be in a separate table, emails are going to be in a separate table. This will allow some users to have phone numbers, some users to have more than one, some users to have none, and so on. Same thing with emails. And of course, we're using the user ID to reference. So you can see user number 1 has one phone number, which is Alice. User number 2, that's Bob. He has 2 phone numbers. User number 3 does not have any, and so on and so forth. So this is another way that is very common in relational databases, to split the data into multiple tables. And of course, once we do that, then we have to use joins whenever we want to combine this data back in queries. If I want to see users with all their phone and email addresses, then I will have to join these 3 tables together. Of course, joins are very common in relational databases because of how the data is split, and they are, they're used in pretty much most of the queries. So this is how the data would look like in a relational database, and how we would represent it and how we would interact with it. If we look at the same data in a document database, like MongoDB, for example, most likely it will look like this. We will have a users collection that will have one document for each user, and it will have whatever information that we have for that user. So you will see the first user, Alice, she has a single phone number. The second user, Bob, he has 2 phone numbers, so we can represent it as an array in this case. The third user, Tom, no phone numbers, but he has an email, so we don't have a phone field, we have an email field. So we can see here that we only put the data that we have. If we want to add a new user that does not have the same information, does not have emails or phone numbers, but has something else, we don't need to modify anything. We just add the new user with whatever data that they have. If the data is different, we just add it. We don't need to do any modification in the structure or something like that. We just add whatever fields that are available for this particular document. The advantage, obviously, is that we don't have any unneeded fields. That's one thing. So all those nulls that we used to have in relational databases, here we don't. All the data is together. We did not have to split it into multiple collections. We don't need to use joins in this particular case. If we want all the data for any particular user, all the data is already there in one place, so we can grab it easily. It is also easy to express multi-valued data, like the phone numbers, for example. When you have an array like this, over there you would have to split this into another table, or you would have multiple columns in the same table, but that's not the best design. So there are many advantages to using a document database for this kind of information. One thing I wanted to note is that even though in document databases you have this flexibility, you have this flexible schema where you can express different information in different documents, many people would rely on that and not spend time actually designing the database in advance, which is not correct. Like, even though you have this flexibility, you still need to put time and effort in designing your database to make sure that it serves your queries well, the data is organized in the best possible way, and so on, because this is not the only way to represent the data, as we will see in a couple of minutes. So you still need to properly design your database. The database design for document databases has a lot of similarity with the database design process that we talked about for relational databases. There are some differences. I will talk about that in a separate video, so not today. But yeah, again, you just need to properly design your database and not just rely on that flexibility and start inserting data right away. So the last thing I want to talk about today is specifically that how is the data linked? If we have multiple kinds of data, how do we link them together? One thing we have already seen is using nested documents. The other way to do it is called referencing. So either nesting, or it's also sometimes called embedding. So that's one thing. And then the other one is referencing. Let's talk about both of them. So let's talk about what we've already seen, the embedding or nesting, right? Let's say we have a users collection, and one of the fields that we have is the employer of each user, right? So we might have the employer information, the company where that person works, and we have it as a nested document within the user document. So again, this has all the advantages that we talked about before. The data is all together. If you want to read all the users' data together with their employer, you can read it in one operation. If you want to update it, you can update it in one operation. So it makes things very easy. The downside of that, as we can see here, is that it introduces potential duplicates. If two users work in the same company, then you duplicate that information twice. And that introduces pretty much all the problems that we've talked about when we were talking about normalization, like when the data is still not normalized or denormalized, as we call it. All the anomalies that we mentioned, the update anomalies, the insertion anomalies, the deletion anomalies, all of that you can find here as well. If you want to update the employer, then you have to remember that there are multiple instances. You have to update all of them, or if you don't, then you might forget, and then you'll have inconsistency. If you delete all the users, then pretty much like there's nothing referring to that company anymore. So all these problems happen in this way of organizing the data. But again, the benefit here is that if you know that you always want this information together, then organizing it in this way gives you the best performance. The alternative to that is the second way, which is called referencing, which is very similar to normalization. Basically, you can split it into multiple collections. So we can have a company's collection and a user's collection. And here we use that ID field that we mentioned earlier to refer to the object that we want to. So we have here, like, each company has its ID. And in the user, we want to say that this user is, working in that company. So we put the employer ID, which refers to that other document. Again, similar to foreign keys, basically, in relational databases. The advantage of that is obviously we don't have any duplicates. The information is recorded only once. So if you update it once. You don't have to worry about all these anomalies happening. Of course, the downside is that if you ever want to read both the user and the company information together, then you have to join these two collections. Joins, there are ways to do them in document databases, but it is not a common operation, so it is not the most optimal thing to do. So that's what I was saying. You need to properly design your database. Knowing what the application looks like, how you want to access the data will tell you whether to reference or to nest the documents inside one another. All right, so this is all I wanted to talk about today. So to summarize, we talked about document databases. We explained how they're stored, what the data model looks like. So we have, on the highest level, we have collections. Collections contain documents that describe entities of similar type. These documents are JSON documents that have fields. These fields, which correspond to columns in relational databases, each field has a name and has a value. The value could be atomic, or it could be a nested document, or it could be an array. Different documents may have different fields, even within the same collection. That's the flexible schema aspect of document databases. And then we've talked about how do we link objects together, either using embedding or nesting, in other words, or using referencing. So again, this was a short video. We just wanted to give an overview on document databases and how how the data looks like. There will be more videos in the future. I will talk about some technical details, let's say in the storage and in the query engine and so on. So if you have any questions about what we talked about today, or if you want to see something specific regarding document databases, please let me know in the comments and I will try to get to that. Otherwise, if you like this video, please hit the like button. Please subscribe to the channel if you haven't already, so that you can get all the updates. And with that, thank you so much for watching, and I will see you in the next video.